Hi everyone! In this video I want to talk about Foundry Agent Service v2, which just went GA. It changes a few things. The API foundation moves from the Assistance API to the Responses API. The security model is also different, and there is more I want to walk through. So let me start with the API because that's the biggest shift. So if I think back to how most of us built agents for the last couple of years, it was very server managed. I create a thread, that's the conversation container. I post messages into that thread, then I kick off a run. And the service kind of owns the whole loop. It stores state server side, it decides when to call a tool, and it does the back and forth until the run is done. The model works, but the trade-off is control. A run is a big black box. If I want to see exactly which tool call happened and when, or I want to change how I handle tool results, I'm fighting the abstraction. Now compare that to the response API style. Here I send one request with the messages I wanted to consider and the tools it's allowed to use. I get one response back, it's stateless, so the contract is here simple. And if the model wants to call a tool, I see it right there in the response. Then I can run the tool myself, I can block it, I can log it, I can even change the tool result before I send the next request. I also get structured outputs and native streaming as part of that same response shape. So it's less the service runs my agent and more I run the loop, the model tells me what it wants. In Foundry Agent Service v2, that shift shows up very directly. Threads become conversations and runs become responses. It's the same agent idea, but it's a lighter protocol. And I'm not locked into one big server-side run. And it matters because Foundry Agent Service v1 was built on the Assistance API. The Assistance API is heading toward deprecation, and it's not where the momentum is for new capabilities. So if I'm writing code today, I want to line up with where the ecosystem is going, which is the Responses API. The nice thing about v2 is if I already have code using the Responses API style, Foundry can add the enterprise layers without me rewriting everything. It's also not just one model. v2 uses a unified project endpoint, so I can use OpenAI, Anthropic, and Foundry hosted models through a common API shape. And on the tool side, at the time of this video, there are over 1,400 MCP connectors available, so I'm not rebuilding integration one by one. And I can mix and match architecture choices as well. I can use DeepSeek for planning, OpenAI for generation, and LangGraph for orchestration, for instance. The runtime is a common layer I operate against, and it's not a framework lock-in. From a developer point of view, the SDK path also changed. The major client is AI project client in the Azure AI project package. And for v2, that's the main thing I'm using. So in practice, I create the agent definition with something like project client.agents.create version. And then when I actually want to invoke it, I get an OpenAI client and call OpenAI client responses create, and I pass an agent reference that points to that deployed agent definition. The agent reference is a bridge between my Responses API call and the agent I manage in Foundry. So my app calls responses and Foundry supplies the agent contract. Now, if I already built on v1, how do I move? There are two paths. The portal-based path is interactive. I open the Foundry portal, I choose upgrade existing agents, and I save each v1 agent as a new v2 agent. And for bulk migration, there is a script-based Docker container that can migrate many agents on or AI or Assistance API workloads, in one go. Two details are important. First, migration is additive. It doesn't delete v1 agents. It creates v2 agents alongside them. And second, it migrates agent definitions, tool, files, and vector stores. It does not migrate historical state, so threads, runs, conversation history that stays behind. That's pretty common trade-off with these migrations. I move the definition forward, but I don't drag the old conversation history along with it. And the scope matters. Prompt agents and assistants migrate. Hosted agents are v2 native, so they are not part of migration. Once I'm on a runtime that matches the responses API, the next thing I worry about is where does the traffic go? Because an agent is not just a model call, it's model round trips, retrieval calls and tool invocations, and every one of those hops is a possible exposure if it goes over the public internet. That's why the security work in V2 is such a big deal. With the standard setup using private networking and bring your own VNet, I can keep the chain on private networking path end-to-end when I set it up that way. So it's not only the inference call that can stay private for tools that sit in my network or support private connectivity. Those hops can stay private too, and that's the part people miss. Now networking is only half the story. The other half is identity. When an agent calls a tool, who is it exactly? And in V2, agents can use a managed identity, that intra-agent identity, so I get proper authentication and audit trails, and it's a big part of publishing into Microsoft 365 scenarios as well. And it scales. I can grow a lot of agents and still keep a consistent identity model. Tool authentication is where real life gets complicated, so MCP supports 4 modes. If I have an internal tool and I just need shared access, key-based auth can be fine using custom keys. And if I want the agent to authenticate as itself, service to service, I use intra-agent identity. If I want isolation as the project boundary, I use intra-Foundry project managed identity. But the one that tends to matter most is OAuth identity pass-through, because in many business apps, the agent should act as a user and not as a shared system identity. If the agent is reading the user's OneDrive or calling a SaaS API that is scoped per user, I need delegated access. OAuth pass-through is how I get that. The agent is effectively operating on behalf of the signed-in user, which with the permission, that user has. So between private networking and a real identity model, the agent stops being a chat demo and starts fitting into the same security shape as the rest of my apps. And you know, security is necessary, but it doesn't tell me if the agent is any good. And the trap I see is teams do a pre-ship test, they feel good, they deploy, and then quality drifts over time. So evaluations being GA in Foundry matters because it's not one thing, it's 3 layers. The first layer is out of the box evaluators. I don't have to configure anything special. I can measure things like coherence, relevance, and groundedness. Retrieval quality, also safety, fluency, and task adherence. That gives me a baseline signal quickly. And the second layer is custom evaluators. This is where I encode what my business actually cares about, internal tone, domain-specific compliance, specific rules that don't map to a generic evaluator. And then the key piece is continuous evaluation. Foundry can sample live traffic, run that evaluator suite, and aggregate the results into dashboards. So quality is not a one-time snapshot, it becomes something I watch. And because it wires into Azure Monitor, I can have alerts when groundedness drops, when safety thresholds breach, or when performance degrades. That's how I catch drift early before users start opening tickets. All of that observability can land in one place as well. Results, traces, and even red teaming runs can publish to Azure Monitor Application Insight. So I'm not building a separate monitoring stack just for agents. And if I want to automate this, there is an OpenAI compatible evals API on AI project client. I define evaluators with openai.evals.create. And the important detail is I can target the real deployed agent using target type Azure AI agent with an agent name and version. I'm evaluating what I actually shipped, and it's done. So the runtime is there, the security is there, I can measure quality. Now there is one more channel. Text is the easy mode. The moment someone says make it voice, everything becomes fragile because now I'm stitching together speech to text, then the LLM, then text to speech. That's 3 latency hops. There is 3 billing surfaces. There is 3 different places that can fail at the end. And when the user says it keeps interrupting me, I'm stuck guessing which part did it. The spoken language interface in Foundry Agent Service changes that by collapsing it into a single managed API endpoint. So instead of me orchestrating STT, model, and TTS, I connect once and it's speech to speech real time. as one runtime. Under the hood, there are a few capabilities that make it feel like a conversation instead of a phone tree. There is semantic voice activity direction, so it's looking at meaning, not just silence. There is semantic end of turn detection, so it can better detect when I am actually done talking. And there is server-side noise suppression and echo cancellation, so I don't have to build a post-processing pipeline. And barge-in support, which is required because real users interrupt mid-response. The integration point is also important. I connect via an agent session config. I point at an agent name and project, and the session is voice enabled. But the agent prompt, tools, and configuration stays in Foundry. The voice layer owns the audio input and output, not my agent definition. And because it's still the same agent runtime, I don't end up with a second system to operate. The same evaluators apply. The same cost visibility applies. Voice doesn't become a separate monitoring world. And at the time of this video, that spoken language support is in public preview, but the shape is clear. Custom support, field service, accessibility, hands-free workflows, they can all use the same agent and just change the channel. So if I'm zoom out, Foundry Agent Service v2 is really about moving from a heavy server-managed assistant API world to a cleaner responses API contract, and then layering what enterprises need on top. So I get private networking across the full chain, real intra identity for the agent with MCP authentication modes that match reality, and evaluations that keep running in production with Azure Monitor and Application Insight. And voice stops being three services taped together, it becomes one managed speech endpoint on the same agent runtime. So that's it, as always, I hope this was useful. Till next video, take care.